Now solution to problem set 3.1 and problem number 3.6. Before I read out the statement, look at this diagram. A rectangular, this is a rectangle A, B, C, D, A. This side is represented by a force P, this side is represented by a force Q. To this side is the same force P and to this side is the same force Q. From here to here the length is A, from here to here the length is B. So this P and this Q will have a resultant R, and this P and this Q will also have a resultant R, and D is the perpendicular distance between them. Now let me read out the statement now. A rectangle ABCD as shown in this figure F is acted upon by two equal horizontal forces. Two equal horizontal forces P. Look, this is one P, this is another P. And two equal vertical forces Q. This is one Q, this is the second Q. Applied at point A and C. Calculate the perpendicular distance between the resultant, this resultant of this P and this Q, and this resultant of this P and this Q. The perpendicular distance we have to find out of the forces PQ at A and the resultant of the forces PQ at C. Before I proceed, I must explain you the parallelogram law of vector addition, which you did in your school days. This is a parallelogram. This side is represented by a force P, this side is represented by a force Q, and the combined effect of P and Q will be this diagonal called the resultant. And if the angle between P and Q is theta and the resultant makes angle alpha with P, these two equations you must have derived in your school days, that square of this R square is equal to P square plus Q square plus 2PQ cos theta. This expression gives the magnitude of R, means given the value of P and value of Q and given angle theta, this helps you to find how much is R. And tan alpha is Q sin theta over P plus Q cos theta. If you put these values, then you look for the tangent table. So this expression gives you the direction of R. Alright. Now what happens if this P and this Q, if theta is 90, means if they are perpendicular to each other, in this expression put theta is 90, so your R square becomes P square plus Q square, and that is same thing as saying R will be P square plus Q square, square root of that. So from this R will be square root of this. Now look, what is to be understood here is this resultant and this resultant, the perpendicular distance between them is D, means the two equal and opposite forces having a perpendicular distance, it will have a anti-clockwise couple. It will have an anti-clockwise couple like this. So this resultant and this resultant having a perpendicular distance D will have an anti-clockwise couple. And how much will be that? And we know couple is equal to the magnitude of the either force R times the perpendicular distance. So R is equal to P square plus Q square, square root of that. So for R I substitute this and D remains as same. And this couple is anti-clockwise. This couple produced due to these two resultants is anti-clockwise. Now let us take the moment of the forces about point A. Now this P and this Q, they are passing through the point A, means this P and this Q, they don't have, both of them don't have any perpendicular distance about A. So this P and this Q, they do not produce any moment about A. But if you look at this P and this Q, this P is at a perpendicular distance A. The line of action of this P from the point A has a perpendicular distance A, and the line of action of this Q from point A has a perpendicular distance B. So this P and this Q will produce a moment. So that is what I have said. So A is the perpendicular distance of the line of action of P at C about A, and B is the perpendicular distance of the line of action of Q at C, not this Q, and this P is not this P. This P and Q. So, sigma MA, sum of the moments about point A. P times P cross P times A. P times A will be anticlockwise. Then y have subtracted Q times B, and this Q times B will be clockwise. So since these two resultants having a perpendicular distance d produce a anticlockwise couple, so if this is greater than this, then the resultant of these two, the combined effect of this and this, will be anticlockwise. That is what I have written here. So therefore this anticlockwise moment will be equal to this anticlockwise couple. So I make them equal. So we need to find d. So this was multiplied here, is taken to the right hand side, so it's divided. So PA minus QB over P square plus Q square, square root of that is the distance between those two, these two resultants which produce anticlockwise couple. So that is all about. So if you find the explanations interesting, feel free to subscribe and feel free to write back also in the comment sections. Thank you.